Hi everyone. So for this video, I'm going to briefly talk about my project, how I did it, what models I used, and how the models perform. As we all know, our goal is to predict the number of dengue cases each week in each location based on environmental variables, describing changes in temperature, precipitation, vegetation, and more. I first downloaded 4 data files in total. The first one, a dengue label string, which has 4 variables: city, year, week of year, and total cases. The second file is dengue feature string, which has 24 variables. I'm not going to just repeat it. And the third one is dengue features test. As just like what we usually do in discussion questions, 1 train data and 1 test data. The fourth one is the submission file that we need to put our final result in. I began by creating 2 data frames to separate 2 cities, SJ and IQ. And for each data frame, I separate them into 2 parts. The first one is used to train the model, and the second part is saved for later comparison with the test data. Now let's go through the data visualizations really quick. So these 2 plots are the total cases weekly in the train data of each city. Here, SJ and IQ, and I also did them in yearly. As we can see from these plots, SJ has a few peaks right here too, but with no obvious pattern in both week and year plots. The IQ has a few peaks here and here, and we can see IQ has a pretty obvious increasing pattern in the yearly plot. And then I did this decomposition of train seasonal noise for each city, and this is SJ and this is IQ. Okay, so same as what we observed from the weekly and yearly plot, SJ doesn't have a clear trend. You can see it's not obvious at all. And IQ has an increasing trend, pretty obvious. And the cases don't show obvious seasonality. Neither one shows seasonality, actually, from the plot. And this one is the same as the yearly one, but I just, make it more clear so you can see like each year, and you can easily tell there's no seasonality here. Okay, so let's go through the models that I used. I first used Hall-Winters method to do the forecast, and we can see that there's a great possibility that the disease cases would increase to a certain amount in the future days in SJ, but stay quite the same for a while in IQ. Since the performance is evaluated according to the mean absolute error, we need to calculate the error for each model in order to select the best one with the smallest error. The mean absolute error for SJ in this method is 58.2, and for IQ is 5.73. Then here goes the ARIMA model. I did this auto ARIMA thing, so they select the order automatically. And for the city SJ is 111, and the order for IQ is 012. So here is the standardized residuals. As we can see, the p-values in both are not large enough, and it doesn't indicate the residuals are independent. The mean absolute errors of a ARIMA model for SJ are 59.2, and for IQ is 5.25. Oh, here's the QQ plot I did for a ARIMA model, and you can see it's not quite good for for QQ plot. The residuals doesn't lie on this this line. The third model I used is Garch model, and I did it with the confidence interval. You can see here, and this one is looks much better. And actually the error, the absolute mean error for SJ is 59.2, and the error for IQ is 5.25. Oops, my bad. So after fitting the data into some time series models, I would like to move forward and see if certain predictors have significant effect on the the future cases. So this one, I used the linear regression model with EIC method. I chose the direction to be both and eventually got the best model for SJ here. And these are the predictors that have significant effect on the model, the future cases. So right here, northwest of city central, southwest, mean air temperature, average air temperature, stuff. I'm not going to just read all. And the best model for IQ for the same method are these predictors. Quite much the same, but with more predictors. And we got the mean absolute error for linear regression model with AIC method for SJ is 22.44, and for IQ is 10.89. Sorry. Quite impressive with the city SJ, but not IQ. Okay, so to sum up, the best model SJ fitted in is linear regression model with AIC method because it has the smallest mean absolute errors, and the best model IQ fitted in is GARCH for the same reason. So I used linear regression model with AIC method to test the train data of SJ, and the GARCH model is used to test the train data of IQ. The result is pretty good. And I also did the predicted future disease cases into the submission file. Overall, I did fine on forecasting the amount of feature cases for both cities, but there are still some improvements that I could make to make it better. So first, the linear model I used to predict SJ is based on the presumption that cases in SJ and those predictors are linearly related. Plus, I assume the error distribution is normal. However, real-life data might not fulfill these two conditions. Also, the GARCH model I used to predict data in IQ, GARCH is a stationary model with also linear process, and there are non-constant conditional variants that could be a potential problem. Thinking about these, the models could be made more compressive and accurate. And that's my presentation, and thank you all.